A hot research topic in the world of cosmology is the idea of multiverses. If we live in a multiverse, it means that there are multiple universes which are completely independent from our familiar universe. In another video, I talked about different thoughts about multiverses, and you should watch it to better understand the idea. But in this video, I want to talk about why scientists think that multiverses could exist. To do that, we need to consider one of the most puzzling mysteries of all, the question of why we even exist. After all, when you think about it, our existence requires some very peculiar coincidences. It requires that the laws of physics be very specific. It requires that gravity work the way it does to make stars form and keep planets orbiting them. It requires that nuclear physics causes stars to burn. Even more basically, it requires that the laws of electromagnetism and quantum mechanics be the way that they are, because that's what's needed to form atoms, molecules, and us. So first, we have to ask ourselves if that's weird. After all, maybe if we change the laws of physics just a little bit, nothing much changes and the universe looks more or less like it does now. Then the fact that we live in the kind of universe that we do wouldn't be all that surprising. I could give tons and tons of examples of tiny changes we could make and what the consequences would be. But let's just pick one example for illustration. This example involves the mass of the proton and neutron found at the center of atoms. The neutron is slightly heavier than the proton, just 0.1% heavier to be exact. Suppose we made the small change that the proton was the heavier particle. What effect would that have on the universe in which we live? You'd think that this would be a tiny difference, but the result is huge. To understand this, you need to know a few things. First, when the universe was young, it consisted entirely of the nuclei of hydrogen and helium atoms. Hydrogen is an atom with one proton, and helium contains two protons and two neutrons. They were created in the unbelievably short time of 3 minutes after the Big Bang. The second thing you need to know is that while atomic nuclei were formed in 3 minutes, actual atoms took much longer, about 380,000 years. So bare protons that eventually became hydrogen atoms existed for a very long time. The third thing you need to know is that isolated neutrons decay into protons and other particles in about 15 minutes, while a proton's lifetime seems to be infinite. The reason that a neutron decays into a proton and not vice versa is because neutrons are heavier than protons. So what would happen if we swapped the masses of protons and neutrons? Well, protons would decay into neutrons and other particles in about 15 minutes. Thus, in the 380,000 years it took for hydrogen atoms to form in our universe, all of the protons would have decayed into neutrons. Without protons, hydrogen gas wouldn't have formed. As gravity pulled the neutrons together, stars wouldn't have ignited in the way that they did in our universe, and with no hydrogen, chemistry would certainly have been very different. With a tiny change of swapping the mass of protons and neutrons, our entire universe has a character that's completely different, and humans would have never existed. I picked just one example to illustrate how small changes can make a huge difference. But like I said before, there are tons of other small changes that would have a huge effect on what our universe looks like. Scientists call this the fine-tuning problem, which means that without many physical parameters being exactly, precisely what they are now, we wouldn't exist. And that's really troubling. It makes the fact that the universe exists seems to be some kind of cosmic accident. Some people take the fine-tuning problem as very strong evidence for a creator of some sort. According to their way of thinking, it took a mindful being to set up the conditions the way they are so we can exist. The name for this school of thought is intelligent design. While some people find that explanation satisfying, it's not without its problems of its own, and most scientists look for a different answer. And that's because the question of fine-tuning is a very real one, and a solution must be found. One answer is pretty simple, and it's called the anthropic principle. Basically, it just says that the universe must be the way it is because we're here to think about it. If the universe were different, nobody would exist and nobody would think about it. That doesn't mean that an empty universe couldn't exist. It just means that since we know that we actually are here, the universe has to be the way it is. That's not a very helpful answer. It boils down to I exist because I exist. Scientists have to do better. So that's where multiverses come in. Maybe not one universe exists, but maybe countless, perhaps an infinite number. That way, in all of the countless universes, all countless choices of parameters actually occur. In some universes, neutrons are heavier than protons, and in some, protons are heavier than neutrons. In some, neutrons might not exist at all. And the list of possible variations goes on much more than that. In some universes, gravity may not exist, or maybe gravity is a repulsive force. Everything that can happen does happen in at least one universe. So you can take the idea of multiverse and combine it with the anthropic principle, and now we have an answer to the fine-tuning problem. We just happen to live in one of the universes that's amenable to human life. Now, you certainly might and should be skeptical about this whole multiverse idea. After all, as I've described it, it's an untestable hypothesis. And we scientists have a phrase for an untestable hypothesis. We say that it's not science. So does that make the multiverse theory not science? Well, no, or not exactly. What it means is that scientists have to be a lot more thorough in their thinking. It means that we have to think through our theories a lot more carefully to see if there might be a testable consequence. And there have been some successes. In one multiverse idea, in which there are multiple universes bouncing around in some higher dimensional space, perhaps the collisions leave an imprint on the universe. There are a few cosmologists who think that a huge cold spot observed when the universe is studied at the largest scales might be the signature of such a collision, like a bruise on a particularly huge peach. So is a collision between universes the most likely cause for this cold spot? No, well, probably not. Personally, I bet that there's a simpler answer. But at this point, nobody really knows. Humongous collisions between universes could be an explanation. So that's the reason, or at least one of the reasons, that the multiverse theory is popular among theorists. It's not a theory you should believe, but it is a cool idea that might, just might, be true.